Hello, and we're back. Trigonometric functions, radian and degree measure, lesson 4.1. You guys, a quick review about angles to begin with. We know that an angle is formed by looking at a vertex. We have a half line, which we call a ray, not a pay, a ray. And we have another half line or ray. When we start to discuss the idea of radians, we're going to have an initial side and a terminal side. And just as it sounds, terminal is where we terminated, where we ended. That measure in between, of course, is our angle measure. We're going to begin the discussion of radian measure, and I want you to read that on page 255, definition of radian. We'll go right here. The definition of a radian measure is this. Radian is the measure of a central angle. Central angle. We're going to talk about this circle being laid over the coordinate plane. Central angle meaning the vertex is at the origin, and it intercepts a length. So if we come out here, we have an angle intercepting this length, this arc length, which in geometry you refer to that as S. That angle theta is that arc length S, which is equivalent to the radius of the circle. So S and R are equal. S and R are the same thing. Theta is arc length over radius. Well, with that in mind, I'd like you to ponder the question, so that's 1 radian. How many radians are there? If we go back and forth between radian and radius, we see that the circumference of a circle, the whole distance around, is 2 pi times the radius. In beginning to deal with radian and degree measure, we're going to work on what we call a unit circle to make things simple, and we can adjust and use different radiuses later. But for now, the unit circle has a radius which equals 1. So that makes it easier. Now, could you tell me how many radians there are in a single circle? Well, that's easy. We know that the radius of our unit circle is equal to 1, and 2 times pi times 1 is that entire distance around. We know there are 2 pi radiuses around this circle. Therefore, there are 2 times 3.14 radians, or for our simple calculating, 6.28 radians in a single circle. So you guys can see from that, if we travel around the outside of the circle, traveling around the outside, we can, and this is obviously not to scale, 1 radian, 2 radian, 3 radians, we can go all the way around. It is written or shown nicely on page 255, about the middle of the page, that there are just slightly over 6 radiuses in the circumference of a circle. There are 6.28 radians in a complete circle. So if we think about that, 6.28 radians, this is radian measure, is equal to 360 degrees in degree measure. And what we're going to do is go into the calculation or translating back and forth from degrees to radians, and that's mostly what 4.1 is all about. I bet your first question is, oh my gosh, did you draw that circle? No, I didn't. I cheated. I used the tool. So here we go. Let's go back to this concept of radians. And when we talk about the unit circle and we talk about a centrally located angle, we know that that vertex sits at the origin. We also know that right here, the positive x-axis is going to be our 0 degree measure. So if we have an angle that's initial side and terminal side hit on the x-axis, we have a degree measure of 0. Now when we take that terminal side of that angle and start to travel about the circle in the counterclockwise direction, this gives us a positive angle. And contrastly, if we move in the clockwise direction, we end up with a negative angle. That concept comes in handy as we're finding coterminal angles later on. What I'd like you to look at right now is the idea of starting at 0 and moving around. I want you to think about this. We know that a straight line, positive x through negative x, if we traveled all the way around the circle to here, we know that a straight line has 180 degrees. We also know that that's half a circle, and the circumference of the circle is 2 pi times the radius, which we are, for our benefit, we're going to use that radius equals 1. So the entire revolution around the circle is equal to 2 pi. Halfway around, it would make sense that was equal to 1 pi. So in the same breath over here on the right hand side, 2 pi is equal to 360 degrees. Well, this makes it easy to start guessing and checking as to what certain types of radian measures look like. If we go through half of a half circle, or up here to the positive y-axis, we know this angle measure to be 90 degrees, and we know that half of pi would give us pi halves. Well, we have 1/2 pi, 2/2 pi. It would make sense that straight down would be 3/2 pi. And that angle measure, if we're counting by 90s, 90, 180, 270 degrees is equal to 3/2 pi radians. So we start to see how simple it is to go between radian measure and degree measure. So let's keep using those powers of pretend like we did when we were little kids. Let's look back at this circle again, knowing that this is positive x, this is negative y, and it's as though the coordinate plane was placed on top of the circle, or vice versa. We can quickly go to estimating certain radian measures when we know 2 pi halfway around is pi, we know pi halves, and we know 3 pi halves. Well, it's an easy concept on page 255. If we just consider from 0 to pi, 1 whole pi, then we can quickly estimate these values. If we take that full pi and cut it into 6 equal portions, there's 1, 2, 3, and 4, 5, 6. We can see that one of those sections would be pi over 6. We could do the same thing with quarters. I'm going to take my green pen now. Here's a fourth. Here's 1/4 pi, pi fourths, pi halves. Same thing over here. Cutting this segment, we'd have 1/4, 2/4, 3/4 pi, and 1 full pi. So we can see that estimation becomes easier once we understand the concept. Please look at the bottom of page 255 and see those other sections that they have gone ahead and cut those into. On page 256, we start to talk about coterminal angles. Co meaning together, simply sharing something. Cohabitating, coefficient. No, that one didn't work. Never mind. So coterminal is simply the concept that they have the same terminal side for an angle. So if we take that and estimate that to be pi what could we call that? How about pi? Well, it's kind of off, but let's call it pi sixth. So we've come from standard position 0 degrees and come up pi over 6 radians. When we talk about the idea of coterminal, meaning that another angle that shares that same terminal side with pi over 6 can simply be found by adding or subtracting a full revolution. So 2 pi we can write as 12 over 6. 12 over 6 pi, and pi over 6, that's 1 pi over 6, plus, so a coterminal angle would be 13 pi over 6, or 1 minus 12, negative 11 pi over 6. And those two angles could be sketched out. The first one being starting at 0, going around 12 pi over 6, plus another 1/6, 13 pi over 6. And the other way we can do this is by coming around a negative angle, negative almost 12 pi over 6, negative 11 pi over 6. So a lot of what we do in math and calculus, especially trigonometry, is to convert from radians to degrees. So going back to that concept that we had just talked about, one full revolution being 360 degrees, we know that from 0 to 360 degrees, 360 degrees is equal to 2 pi radians. And so if we look at that, we can see that radians, if we divide both sides by 2 pi, radians is simply equivalent to, oh, come on, hang in there, not going to work. Radians is simply equal to, and this is going to be our conversion factor, 180 over pi. And we remember this because from 0, that half circle, or 180 degrees, was the same as our measure 2 pi cut in half. So 180 equals pi radians, and this will be our conversion factor from this point on. I'd like you to go ahead and look at example 2. Let's go through one of those if I can get this thing to work. I'm looking at example 2, part A. We're going to take 135 degrees and convert to radians. Well, the way that we do this is to use our conversion factor. We want to get rid of degrees and multiply by radians. Radians to degrees. So we take that simple fact that we just talked about, radians to degrees, that is pi radians equal to 180 degrees, and we will see degrees canceling out, and we're left with 135 pi over 180, and this gives us the measure or the unit radians, and we can see that that simplifies to 3/4 pi radians. If you guys think about that, the other thing that we want to be able to do quickly and easily is to determine what quadrant that value lays in. Lies, excuse me. Inanimate objects lie. That's your language arts lesson for the day. So if we know this to be pi 0, this is pi halves. I know that 3/4 lies right there. 1/4, 2/4, 3/4 pi. And it would make sense to us, I would hope, that that would also be representative of 135 degrees.